Hi, I'm John Fennell, and this is part of my Mock 1 Task 1. I'm going to build a Zener diode circuit. Okay. Focus. Okay, so first thing I'm going to do is connect my 100 ohm resistor from the positive rail across to line 10. Then I'll connect the Zener diode, which goes to the negative rail, and then the 10 kilo ohm resistor, which links also to the negative rail. I'll connect the battery. There we go. Okay, so to prove this works, I will quickly test the voltage on the load, which is the 10k resistor. So direct. And as you can see, we have a voltage of 6.37. Hi, it's me, John again. This is task 1 of Mock 1, the Zener and potentiometer circuit. Okay. Okay, first I'll attach the potentiometer. There will do. This part up to the live bar. And the ground. It's a 100 ohm resistor. Right spot, there we go. And then that will lead into the Zener diode to ground. A bit fiddly these. And the 1000 ohm resistor also into ground, acting as the load. Okay, I'll collect the battery now. Ground. Positive, and let's see if it works. Wrong way. There we go, that's got a 8.5 volts, and then once it gets down to the start of the Zener, we should have, yeah, near enough 6.2. Okay. Hey, it's John again. I'm just going to go through analysing of the circuits, the potentiometer and the Zener diode again. I'm going to basically go through different input voltages and see what difference that has on the voltage across the Zener diode. Okay, here's the circuit again. See if I can get it all positioned so you can see. Right, so the first reading we want is 9 volts supply, we've got 8.5. My battery must be going a bit, so we'll start at 8.5, and that will give us 6.3 across the Zener. Right, this is really sensitive, so bear with me. So 8.4, not that sensitive then. Ah, it went wrong way, that's why. Idiot. Okay, so we're on 3. I'm trying to get 8. That'll do, 7.9. And across the potentiometer we've got 6.25. And we've got 7. Across the potentiometer, across the Zener, 6.19. Close to our 1.8, isn't it? One, 2, 4. Okay, we'll go for that, 7.1, near enough 7. There we go, 6.22. Okay, 6.6. Okay, so we drop down to 6 now. So basically the Zener should have stopped reverse breakdown. So now we're on 4. And the circuit voltage is down to 3 now. So basically, as you can see, anything above 6.2 input stays at around that much, maybe 6.3, 6.4 is the absolute max, even when it's got 8.5 volts coming in. So that's the circuit working, as you can see there. Okay, thank you. Hello, it's John again. I'm going to build the circuit with the LED and transistor. This is for task 1 of mock assignment 1 as well. Okay, let's get to it. Board. Come on, focus. Cool. Okay, so first thing we're going to do is put in the ballast resistor, which is 330 ohms. So we're going to go from the live line into here. Okay, here we go. That's going to lead into an LED, which in turn is going to connect to the collector on the transistor. That's the second 22k resistor, which is going to be connected to the base from the live as well. Then the emitter will be connected straight to the ground line, which is here. Okay, so here's the transistor, the emitters nearest the tab, so that won't go on there, so we'll slide that in like that. We'll cover the LED, the base and the emitter. Don't need that. Okay, let's get some power on the circuit. Positive ground and positive, excellent, lights come on, that's always a bonus. Okay, let's test it and see what we've got. So we're looking to test the voltage at a few different levels for a table, which I've got on the computer. So using the voltage, I'll use the emitter for the ground, and we want the voltage from the supply. So there we go, 8.7. We want the voltage at the LED, so going in, which is just here, 2.3. The voltage at the base, 0.73, so that's just enough to cause the base to turn on the transistor. And then we want the voltage at the collector, which is actually the other end of the LED. And we've got 0.09798 on that. So there are voltages. What we also need to do is take the currents. So we want the current at the base and the current at the collector. So we do the collector first. I'll create a gap there. Oh no, that's not the collector, is it? We want to go from the LED to the collector. There we go. So you can still see this. Okay, so we're going to go from the LED just there onto the collector. And we've got 21 milliamps there. Circuit back working again, and then we're going to get the base current. Okay, let's connect that in there. So fiddly on this, make sure I'm not touching anything else. And there we go. And we've got 2 milliamps there, so very small current going through that. Doesn't seem right to me, that. Yep, 2, sometimes 3 milliamps, so it's a really, really small current. Okay, that's it, all working. Thank you. Hello, me again. We're just going to modify the circuit of the LED and transistor to make it so there's 10 milliamps current across the collector on the transistor. Okay, so I'll show you what I've done. This is the circuit. Still set up how it was before. Through the calculations, I've worked out that we needed a 700 ohm fuse, but I don't have one, so I'm using a 680 as it's the nearest. So I'm going to take out the 330 and replace that with a 680. I'll show you that the circuit works. Connect that from the ballast to... Oh, that's why I've got it in the wrong hole. There we go. Cool. So that's the circuit working. So I'll measure the current across there. Bring this out so I can connect it in serial. Connect them up. And there we go. If you can see that, we've got that actually going at 12. Last time I tested it, it was 9.6. So the calculations aren't too far off. I assume it's just difference in the battery or something like that that's making the difference. Okay, there we go. Thank you.